Hi. So, is it possible to design a lookup table which we can utilize to get the product of two numbers? This is what we'll try to respond here. So, if you observe, product of x and y here can be written in this manner. Okay, and let's consider the lookup table of this form where we are doing just we are squaring it, we are dividing by 4, and we are considering the nearest integer which is less than the number you are going to get. Okay, which is easily computable as you can see. And now let's consider following relations like x and y given in z. Then one can see that these two things are congruent modulo 4, which basically means that the remainder after dividing by 4 of this number will be the same. Okay, a is congruent to b modulo n if n divides a minus b. That's the definition. So if Q and Q1 are quotients and R and R1 are remainder, one can easily check that R and R1 are same. Okay, from equation 1, and from which we can by simplification see following three equations. Okay, and now getting back to the first star equation, one can see that since remainders were equal while we were dividing by 4 of these two numbers, we can conclude that product xy is nothing but difference of q and q1. So basically what it boils down to is like product xy can be written, can be calculated in terms of difference of quotients. So for example, over here if I had two numbers 2 and 3, okay, so 2 plus 3 is 5 and 3 minus 2 is 1. So this difference and sum of these two numbers belongs to this lookup table. Okay, this is what I'm mentioning over here. If x plus y and x minus y from 0 to 5, in fact, okay, 0 to 5, if it belongs, then one can produce xy. Okay, that's what we are producing. So 2 times 3 can be produced in following manner: 6 times 1, okay, element from 1. So 3 minus 2 is 1. That's it. Excellent, yeah. So 3 minus 2 is 1 and hence 0 over here. So 6 minus 0 is 6, hence 2 times 3 equal to 6. Thank you so much.